Hello, and welcome to Noel's Retro Lab. Today we're going to continue with this Amstrad CPC 6128. Last time we looked at the floppy disk drive and we successfully fixed it, but we still have no idea if this is actually working. So today we're going to open it up, we're going to look at it, and we'll see if it works or not. If maybe it's already working and it will be a 5-minute video. But if not, I will follow the procedure I usually go through when fixing one of these computers from the beginning to the end, so you see sort of the reasoning and how we arrive to finding what's wrong with it. So let's open it up and find out. The first thing I like to do when looking at a computer for the first time is just to have a visual inspection of the board. So I open it up and I get a general idea, and I look for things that are obviously wrong or obviously modified by somebody else before, which might give me a hint of something that it's maybe already happened that was wrong and could be a problem again, or a repair that was done incorrectly. So in this particular board, everything looks pretty good. It's not even very dirty. The connectors are really rusty, but that's fine. That's totally normal. There isn't that much dust. I'm not seeing anything socketed that it's not supposed to be socketed. So we have the gate array socketed. That's fine. The CPU, the Z80, and the PAL is socketed. That's standard from the factory. Later we'll have a look at the back. Sometimes you see some bridges that people added, but from here it looks really good. I'd say that nobody's messed with this board. So that's encouraging. Next thing I like to do is to turn the computer on, but when possible with a bench power supply. And that's because a bench power supply, we can control the maximum current that it comes through. So I'm going to turn this one on right now. And I already have it preset to Amstrad. So the Amstrad, the main board, not the floppy drive. The floppy drive uses 12 volts, but we don't even have it here right now. We don't need it. The rest of the Amstrad uses 5 volts and it usually draws about 1 amp. What we have here is the bench power supply is set to 5 volts and is set to a maximum current of 1.2 amps. That's because if there's a horrible short somewhere, it's at most going to draw that current and then it's going to stop. So the voltage will drop. What we're doing is preventing potentially something from getting worse. So it's a safety check. And it's also really good because it lets me know how much current is being drawn, because the opposite also gives you a lot of information. If I turn this on and it doesn't use about 1 amp, if it only uses half an amp, I know there is something in the board that is not activated, that is not working as it should, because it should be drawing more current. When I turn this on, it's going to change from the desired voltage and the maximum current to the actual voltage that is putting out and the actual current that is being drawn. When I turn on the power supply, we're going to see a very small current draw even before I turn the computer on. And that's, there we go. So it's like 0.26 amps. That's just because the video cable is actually powered through the same power supply, so it has a minimum draw in there. So that's fine. So far, so good. And now I'm going to turn the computer on, and let's see what happens. I'll be ready to turn it off really quickly. If this maxes out to 1.2 amps and I see the voltage dropping, I'll turn it off right away. So, oh, nothing happened? Oh. Okay, that was kind of weird. So the current draw, it's reasonable. It's 0.85 amps. That's close enough to the 1 amp. I could be convinced that it's working. Maybe it's a little low, but it's fine. The really weird thing is that I turned it on, it did nothing for about a second, and then it started drawing current. It could be a bad switch. This switch is often a cause of problems. Like people say, oh, the computer doesn't work. It's actually the switch doesn't work. You turn it on and it doesn't make good contact and it just doesn't draw any current. So you see that. You turn it on and there's no current draw. Let's try that again. Turn it off. We're back to that current draw. Turn it on. Okay, so maybe the switch is dirty and the contact is a little iffy. I was so focused on the current draw, I'm not checking whether it's actually working or not. Let's set up the camera and try it out. All right, I've set up the other camera, I've turned on the TV, and let's see if we actually get some image out of this, and if so, what kind of image it is. It's already plugged in. Let's try it. Oh, nothing again. The switch is definitely bad. Okay, draw, and we get no image whatsoever. Okay. Well, we know two things that are wrong already. The switch needs to be cleaned up, but we're getting no video out whatsoever. That's a little unusual, especially with this current draw. I mean, it could be that the Z80 is bad. That's an easy check because it's socketed. But we'll go in order. Let's turn that off. The first thing that we're going to do is check the voltages on the board to make sure that they're approximately right. Here I have my cheapy multimeter, and we're going to be measuring DC voltages. Let's switch the computer on. Okay, the switch worked right away. So yeah, it's very iffy. And first, let's just check the voltage right at the source. So it's center positive, this particular one. So that should read about 4.5. It's a little low. I think it works. The Amstrad boards tend to run at a lower voltage. I've seen them mostly 4.7, 4.6 something. You know what? The switch, if it's dirty, could act as a resistor and lower the voltage. So that's a possibility. Although that wouldn't happen at the source. So let's check a few other things really quickly. So let's check this is the memory right here. Let's check a memory, and yeah, even lower, 4.3. That might not be enough for it to work. I also like to check some of the furthest away. So the AY chip is kind of out in the side of the board, and I believe it's 3 and 6 are maybe the other way. 6 maybe ground, and 3 is 4.3. Let's start checking the switch, and let's do a good cleanup. To get to the switch, I'm going to disassemble everything because we also want to look at the back of the board and have easy access to it in case we need to start desoldering some chips or checking some traces in the back. So let's take it apart. This is the LED light and the speaker. Carefully remove the ribbon cables for the keyboard. Here I can unplug this. This is the 12-volt cable for the floppy disk drive. This is the volume control, which is tied together to the switch. The switch is this yellow cable, and this one comes right up, and this one doesn't have a screw or anything. And I need to pry it up with a screwdriver like that. Okay. I'm going to look at those in a second, but while we're at it, I'm going to take out the board itself. One thing I do when I'm disassembling a computer is I like to have a little box like this with like small compartments where it's easy to put the screws for the different parts, and that way they don't get mixed together. So I'm not gonna mix the screws for the board with the screws from the floppy disk drive or the ones for the case. They can all be separate. That's it. Okay. Yeah, it's a little dirty. We'll be cleaning that in a future episode. And let's look at the back. Okay, the back looks good. There are no bridges, there are no cables that anybody's made. And I don't see any signs of soldering after the factory. So I don't think anyone is messed with this board, which it's always good news. Here we have the switch and the volume control. They're tied together. There's really absolutely no need for them to be tied together, so I can just carefully cut that without damaging the cables. So this switch, it's really, really basic. And to open it, we just need to bend those little tabs that are going to separate this front plate, and everything inside will come out. So you should like to do it. Like start with a screwdriver. like so. Just force him open a little bit. And like that. And the other side as well, a little bit. There we go, like that, and like that, and oh, okay, that was good enough. So this comes out, and as you can see, there's a plate in there. Let's see if I can get the light just right. There's a plate, and that plate is rather dirty. Here, I'm gonna take it out and show it to the camera. Let's see if you can see that. Look at that. That's filled with grease. Yeah, that was not making very good contact. So we just need to give this a good cleaning in some of the other parts of the mechanism. So as usual, some alcohol and cotton swabs works great. Just like that. Okay, look how much shiny it is already. We need to clean not just that part, but actually the part that makes contact. Underneath. Yeah, look how this is coming out. This is all junk that was preventing us from having a good contact in there. This is a very, very common problem. I definitely recommend doing that in any Amstrad that hasn't been serviced in a while. So yeah, give it a good scrub in there so the metal is clean. And then we don't really need to, but I'd like to do this as well, just whatever grease was there. But that part is not actually making contact. This part, this little tip, just slides this metal piece back and forth, so it makes contact from here to there, which is really, when it's on, it bridges those two points in there. So to reassemble it, I just put it back in. There we go, just like that. And we need to make sure that this is on top of it also, because there's two tracks. So that needs to go on top of it like this. And we just need to put it back in place. Yep. You can even try it before closing it completely. Perfect. And now we're just going to put those tabs in place with some pliers. Just like that. And then same thing with those. Okay. And let's even test it. And this time we'll put it in continuity mode. So whenever there's continuity, it will beep. So it should not beep like this because the switch is off. Okay, that's fine. And if we turn it on, perfect. Okay, let's try it again on the computer. This is just the board this time. We don't need the case for anything. And the switch is still not connected. Plug in the switch. It's in the off position. We turn it on again. And now I turn on the switch. Okay, now we got that right away, which is great. So I don't think there's any delay. It just turns on right away, which is great. Let's check to see now if the voltages are any different. I don't really expect them to be, but just in case, before we move on. Voltage right at the source is still 4.5. And at the AY chip, yeah, it's pretty low, but it's within the range of reasonable things. Before we go any further, I think I want to check to see if there is activity on the board and what kind of activity there is, and whether there's something weird going on around the Z80 or the gate array. Here we are, ready to have a look at the board. Actually, one thing that you don't see from the camera, let me see if I can fix this without making a mess, is that I have in front of me, I have the circuit schematics of the Amstrad CPC 6128. So I can be using that as a reference when I'm working on the board. That is super handy. I tend to do that with every computer that I work with. Okay, so we're going to use the oscilloscope to check that the board is actually working, and there's some activity around the Z80 and the gate array. And so the first thing I'd like to check is the clock signal on the Z80. Is the Z80 getting a clock signal? And that happens in pin 6. So let's see, it's right here. So there we go. We're seeing, if we zoom in, it even says that, yeah, it's a 4 megahertz clock signal. So that's perfect. That's encouraging. The gate array is probably working. Now let's see if the Z80 itself is working. The ways I check it is to see, is it sending memory requests? So pin 19, there should be activity here. And yeah, there's activity. It's a little ugly, but there's activity. And the other ones that I check are M1 and refresh. 28, there we go. Or that's 28 and 27. Yeah, so the Z80 seems to be active. Let's see if there's something in the data bus. The data bus are those pins around here. Actually, that's the clock one. So right after that, it's a little ugly. We can catch a single sequence. They're a little ugly, but I mean, you definitely see low levels and high levels. So yeah, it's probably fine. Those are fine. So look at address. Yep, address are fine. They're even a little neater. Yeah. So I'll quickly check all the bits in the data bus. Unfortunately, in the Z80, they are completely jumbled and they're not in order, so it's difficult to just go like that. So I'll just do it in one of the memory banks. The input and the output are going to two different sort of buses. So the input bit into the memory is bit number 2. So this is the one that is connected to the Z80. So yeah, we have some activity and yeah. So the reason I'm looking at this is like if one of them was completely low or completely high, then we would have a problem. Probably the memory chip itself will be shorted out really badly. So those inputs look about the same. And then the output is on bit 14. So it should be this one. And yeah, we have something there. It looks a little weird. They look a little weird. Yep. And let's look at CAS, which is bit 15. Yeah. Yep. Yep, they look about right. So one thing I haven't checked before is whether one of the chips gets hot. It's a pretty good tool to see if something is shorted out. The reason I haven't is because the power draw is not very big, so I doubt anything is getting particularly hot. Just like that, I don't notice anything out of the ordinary. I mean, the Z80 gets a little hot. This guy gets a little hot. Yeah, I don't see anything odd. So at this point, the activity looks about normal. My bit is still on the Z80 itself because we're seeing no image whatsoever. So maybe the next step is to change it out and try it. Ideally, the best thing to do is to take this Z80 and put it on a working computer. It doesn't have to be an Amstrad, it could be anything, and make sure that it works there. Because if you just put another Z80 here and we get no image, then we don't know for sure. Was the Z80 faulty? And there is something else on the board that is preventing it from showing an image or not. Okay, so here's a different computer that we're gonna run the tests for those chips. This is an Amstrad CPC 464, the earlier model with a long board. But the key thing is that it has the same socketed CPU Z80 and the gate array 40010. So let's go ahead and test it out. First, let's test that it works. And okay, it runs perfectly fine. Great. So let's start with the Z80. So now we're going to put the Z80 of the 6128 we were just testing a minute ago. And okay, it starts out fine, so that's not it. Now let's test the gate array. Same thing. And put the other one in. The gate array is actually a custom chip made by Amstrad, so it's one of the more expensive ones to replace. Turn it on, and it's still working. Okay, so we've managed to eliminate the Z80 and the gate array as potentially faulty. So the problem must be somewhere else. Let's keep looking. All right, this is taking longer than I expected, so we should probably stop here for the day, and we'll continue in another video. It looks like we haven't made much progress, but we are eliminating things, and we fixed the switch along the way, so this one works now. And we've managed to eliminate the Z80 as being a source of a problem and the gate array. And we also know that the board sort of seems to work. The voltages everywhere are correct, and we see the traffic we would expect around the data bus and the address bus. So that's all good. But we still need to figure out why is there no video out. If you like this video, click the thumbs up and subscribe to the channel. And I will see you in the next video when we finally fix this. See you then.